At our vision has always been to be world leaders in autonomous digitalization of really challenging, hard-to-reach environments, especially where there's no GPS. This includes mapping areas like underground mines, nuclear facilities, underneath structures like bridges, or even construction sites. We launched the first Hovermap almost 3 years ago to solve this really challenging problem, and it's become a game changer for many industries, particularly underground mining. Over the last few years, we've been hearing feedback from our customers. Although they love Hovermap, they're still looking for something that's even lighter, more versatile, and more rugged to allow them to capture data in even more challenging environments, but without jeopardizing the quality of the data that's produced and the autonomy capabilities. Today, we're really excited to be launching Hovermap ST, the next evolution in survey-grade autonomous LiDAR mapping for harsh GPS-denied environments. It's smaller, lighter, tougher, better IP rated, and can be used in a wider range of temperatures, and also has more powerful onboard processing and an accessory expansion port. This all means that it's now possible to capture exquisite 3D LiDAR data in even more challenging and harsh environments. So I'd like to take a look at some of these great new features that really set Hovermap ST apart from anything else on the market. First of all, it's been totally redesigned from the ground up to be tough, light, and rugged, without compromising the mapping and autonomy qualities. It's built from machined aluminium together with a tough composite plastic shell to make sure it's rugged and weather sealed. Weather seal design ensures it can be used in rain and in dusty conditions. We've achieved this by removing the vents and replacing that with an actively cooled heatsink on the top of the device. This heatsink, together with the internal components we've chosen, allow Hovermap to now be used on a wider range of temperatures, ranging from -10 degrees all the way up to 45 degrees. Hovermap ST is now smaller and lighter, and that's critical for drone-based applications. It can now be used on smaller drones, or the flight time is prolonged when used on existing drones. Another key change is the rotation angle of the LiDAR. It's now optimized to increase the field of view around the drone for collision avoidance and mapping, particularly giving more visibility behind the drone, which allows it to fly through tight spaces while still being aware of what's around it in all directions. The redesigned internal gimbal mechanism now uses precision machined aluminium components to ensure there's rigidity and stiffness where it's needed most for accurate mapping. This, together with the high-resolution encoder, more precise timing circuitry, and the latest iteration of our SLAM algorithm, make Hovermap ST able to produce better quality maps than ever before. Hovermap ST includes a ruggedized embedded computer with high-performance CPU. This allows Hovermap to run more sophisticated autonomy algorithms, improving the autonomy flight capabilities. This also allows Hovermap ST to run the SLAM algorithm on board and produce a point cloud for download, so there's no longer the need for post-processing of raw data to produce that point cloud. SLAM-based systems do, however, suffer from a couple of limitations. One is that the point cloud that is produced is not georeferenced, so there's usually a further step in the workflow to take that local point cloud and georeference that to a known coordinate, and that can take some time. A second limitation is that some environments are not great for SLAM systems, and SLAM can experience some slip or drift in these environments if they're not feature-rich. For the last 2 years, our engineers have been working really hard to find a solution for this problem, and today we're really proud to announce and launch our automatic ground control points, which will alleviate these issues. Our automated ground control point solution involves putting ground control points in the environment, and these are simple retroreflective discs that are placed in the environment and then surveyed in so the coordinates are known. And then you use Hovermap as usual. You'd walk around the environment or fly to capture data, ensuring that those targets are scanned. We then have an automated software workflow which automatically detects the targets in the scans and uses them in 2 ways. First of all, the targets are used to georeference the point cloud and move it into a known coordinate frame automatically without any human interaction. Secondly, we use the targets to improve the SLAM result. They are used as additional constraints in the SLAM solution, eliminating drift and increasing the accuracy and precision of the SLAM map. I'm really excited to see what our customers will do with this powerful combination of Hovermap ST with the auto control points. I really believe this is going to revolutionize SLAM-based mapping in challenging, harsh environments. And also what's very exciting is that it will allow SLAM-based mapping in environments that was previously not suitable for SLAM. Applications like tunnels with smooth walls, long linear assets like power lines, or large, wide open areas that are previously very hard to use a SLAM-based system for are now all possible with this combination of Hovermap ST and our automated GCP points. This really combines the best qualities of a SLAM-based system, which is fast, versatile and easy to use, with the accuracy of a traditional survey tool. So it now means you get the best of both worlds, fast, accurate mapping in any environment.